Given question, draw shear force diagram and bending moment diagram when internal hinge is provided. When hinge is provided in the system, it transfers axial forces as well as lateral forces. But the bending moment at the point of hinge is equal to 0. When to draw the free body diagram, we have to separate the given system at the point of hinge. If we observe the given diagram, then at point C, hinge is provided. We will draw the free body diagram and we will make its parts. First part will be part A, B, C and second part will part C, D. So we will first draw the free body diagram of the second part C, D. Now if we observe at point D, fixed support is given. So we will show here the reaction at the fixed support, which is in vertically upward direction, and it is RD. Now this total span CD is having uniformly distributed load 4 kN per meter over the length of 2 meter. So what is the total load? So total load is equal to, for 1 meter 4 kN. So for 2 meter it is 4 multiplied by 2, 8 kN. So how to show its total load? So point of application of this load is the center point of this total span CD. So I will show here 8 kN load at the center point. Now we will move to the point C, which is the hinge point. So here the point C is at the in the first part as well as in the second part. So I will mention here the point C. Now for this hinge point, how to show the forces? So for these 2 points we have to show vertical forces as well as horizontal forces, which are equal in magnitude but opposite in direction. Now suppose at point C, if I show the force which is in vertically upward direction and its magnitude is equal to Cy, then in the first part we have to show the same force but equal in magnitude but opposite in direction. So I will show here. Now we will show the horizontal force. So same magnitude but opposite in direction. Now its a magnitude, because it is horizontal, we will consider as a Cx. To find out the unknown forces Cy and Rd, we will consider the equilibrium of this part CD. So we can say that summation of all vertical forces is equal to 0. So these forces are in upward direction and this 8 kN is in downward direction. So Rd plus Cy is equal to 8 kN. Now if we observe, this beam CD will act as a simply supported beam because these reaction forces are at the end points. So this 8 kN is equally distributed for this at point C and at point D. So we can say that Cy is equal to Rd is equal to 4 kN. Now we will move to the first part. Now in the first part we have to show the 6 kN point load at point B. Point A is the fixed point. Now at this point A there is vertical force as well as horizontal force. So we have to show the reaction at point A in vertically upward direction, and because this is the vertical force we will say Ay, and the horizontal force we will say Ax. Now if we observe, this part A, B, C is fixed at point A, and at point B and at point C there are 2 point load which are acting in vertically downward direction. So it will move in the downward direction about this point A. So we have to take the summation of moment of these 2 forces about the point A. So how to calculate this? So we know that this moment of this force 6 kN about point A. So if I move the compass in downward direction, then here is the clockwise direction, and for clockwise direction we will consider positive sign. So with positive sign 6 multiplied by 2 plus, because if I move the compass in the direction of Cy, then it is also in clockwise direction. So plus this Cy multiplied by total distance is 4. So value of Cy is equal to 4. So we will take 6 multiplied by 2 plus 4 multiplied by 4, and that is equal to 28 kilonewton meter. So what is the direction of this bending moment? That is in clockwise direction. Now to balance this, or to prevent this bending against the fixed point A, we have to apply the same magnitude moment but opposite in direction. So I will show here. Here at point A we have to provide the moment in the opposite direction, and its magnitude is 20 kilonewton meter. Now this value of Ay is unknown. So how to calculate this? So if we consider this part ABC in equilibrium, then we can say that summation of all vertical forces is equal to 0. So which are the vertical forces? Cy, then 6, and this Ay. So we will take the positive sign for downward direction and negative sign for the upward direction. So Cy plus 6 minus Ay is equal to 0, where Cy is equal to 4. Therefore Ay is equal to 10 kilonewton. So we have to mention the magnitude. Ay is equal to 10, Cy is equal to 4, and Rd is also equal to 4. Now if we observe, there are horizontal forces in the system, but to draw the shear force diagram as well as bending moment diagram, there is no any contribution for these horizontal forces. So no need to calculate these forces. Next step is to calculate shear force. It is the summation of forces either on the left hand side or on the right hand side of the selected point. We are going to use these sign conventions. For this question, we will take the summation of forces on right hand side of the selected point. Now if we observe the directions, then if on the right hand side force is in downward direction, use positive sign, and if force is in upward direction, use negative sign. And these sign conventions you have to mention in the answer sheet. If we move to the part CD, then for these 2 points there is uniformly distributed load as well as point load Cy and Rd. So whenever there are 2 types of load at any point, then we have to find out the shear force at the right hand side and left hand side. Now we will first select the point D, and we will select the point which is on the right hand side of this D. So how to calculate shear force? Summation of forces on right hand side. So on the right hand side there is no any force. So on right hand side value of shear force is equal to 0. Now I will select the left hand side of this D. Now on that is, it is nearer to this point D. So if I select this point, then on right hand side there is the force which is in upward direction. Then for upward direction use negative sign, and its value is 4. So which is equal to minus 4 kilonewton. Now we will move to the point C. So I will select the right hand side point. So on right hand side point there are 2 point loads. That is, this is the uniformly distributed load, but we have converted into point load, and we have to select this point load. Now how to calculate this? So this is in upward direction, so use negative sign. Minus 4. This is in downward direction, so plus 8. So 8 minus 4 is plus 4 kilonewton. Now I will select the point on left hand side. So on left hand side, if we observe, there are 3 loads. So again we will make calculation. Here is minus 4 plus 8, and here is minus 4. So if we calculate this, it will become 0. Now we will move to the part first, that is this ABC. So again we will select the point C. So at point C, if we observe, there is only 1 point load and it is in downward direction. So if the load is in downward direction, then use positive sign. So here plus 4 kilonewton. Now if we observe the point A, B, C in the first part, there is no any uniformly distributed load and only point loads are acting at these points. So there is no need to take the right and left hand side. Now shear force at point B. Now if we observe, there are two loads, that is here is 4 and here is 6, and both are in the downward direction. So we will use the positive sign, that is plus 6 plus 4, that is equal to plus 10 kilonewton. Shear force at point A. So there are three types of loads. So again we will select plus 4 plus 6, and this AY is in upward direction. So use negative sign, that is minus 10. So it is 0 kilonewton. Now we will plot the shear force diagram. So we have to first show the baseline, and on baseline, if we observe, this is the line where we will have to plot these 0 numbers, and positive numbers we have to plot in upward direction and negative numbers in downward direction. Now if we observe the point D, here is 0, so I will plot here 0, and then left hand side minus 4. So I will plot the minus 4, that means we have to plot this number in downward direction. Now how to connect this? So we will connect all the points from right hand side towards the left hand side. So if we observe on right hand side, here is the point whose value is 0, and after 0 there is the value minus 4. So these two points are nearer to D. So these two values we have to plot on the same line, and we will connect these 2 points. Now we will move to the point C. Now if we move towards this left hand side, then here is the point which is on the right hand side of the C. So its value is plus 4. So I will plot here in upward direction because of its sign. Now how to connect these 2 points? If we observe on span CD, uniformly distributed load. So we know that shear force will vary linearly. So we have to show here the inclined line. Now we will move to the second part. So for second part at point C, again plus 4 kilonewton. Now we will move to the left hand side. So we have to take the value of B. So shear force at B is plus 10 kilonewton. So we have to plot here the number 10. Now shear force at A. So at A the value is 0. So we will plot here the 0 number. Now important point, how to connect all these points. If we observe, span AB is having only point load. So we know that whenever point load is given, for that span we have to show the constant line for the shear force. So along the span AB, I will show here one constant line. Then for part BC, so part BC is also having the point load. So we have to show the constant line. So here for this part BC, we have to take this extension from this point C, that is from this point 4. And if we observe at point B, shear force is changing from 4 to 10. So I will connect this. And we will connect this 0 and 10. If we observe the shear force diagram, then there is the point of intersection at which value of shear force is equal to 0. We will give the notations as a point P for this point. Now, how to find out the distance of this point P from this point C? So we will connect this point C, and here is the new point Q. In the same way, we will connect this point D to the point R. Now there are two triangles which is having common horizontal line and common inclined line. So these two triangles are QCP and other triangle RDP. Now for these two triangles, we will take the ratio base to the height. Now for these two triangles, here is angle 90 degree. Now base for the first triangle is CP and height is CQ. In the same way, for the second triangle, base is PD and height is DR. So we will equate this base to the height because these two triangles are similar triangles. Now we will put the values. Now CP, that is the distance we have to find out. So we will write CP as it is. Now value of CQ. So value of CQ is from 0 to 4. So we have to take the magnitude only, that is 4 is equal to PD. So how we will rewrite this PD in terms of CP? So it is CD minus CP. CD minus CP divided by DR. So we have to consider magnitude only. So it is 4. Now CP divided by 4 is equal to value of CD. So it is mentioned in the question 2. So 2 minus Cp divided by 4. Now we will simplify this. 4 Cp is equal to 8 minus 4 Cp. So I will transfer this 4 Cp to the left hand side. So 8 Cp is equal to 8. And therefore Cp is equal to 1. So distance of the point P from C is equal to 1 meter. And we have to mention this distance. Next step is to calculate the bending moment. It is the summation of moment of all the forces either on the right hand side or on the left hand side. For this question, we will consider the summation of forces which are on the right hand side of the selected point. We are going to use these sign conventions. Now if we observe the right hand side, suppose the moment is in clockwise direction, use negative sign, and if moment is in anti-clockwise direction, use positive sign. Now we will first consider the part CD. Now if we observe, we have calculated the distance of the point P from the point C. So we will select here the point P, which is at a distance of 1 meter from these 2 points, that is, this is the center point. Now we will calculate bending moment at point D. So if we observe, there are no any forces on the right hand side. So bending moment at point D is equal to 0. Then bending moment at point P. So on right hand side there is only one force which is in upward direction. So if I move the compass about point P in upward direction, then there is anti-clockwise direction. So use positive sign. So how to calculate this? 4 multiplied by this distance in between P and D, that is 1. So it is equal to plus 4 kilonewton meter. Now what about the point C? So at point C, hinge is provided. So when hinge is provided, then at the point of hinge, bending moment is always equal to 0. So when we calculate the summation of moment of these two forces about point C, then calculated value is also equal to 0. Now we will move to the next point. We will move to the bending moment at point B. So if we move the compass in the direction of CY, that is, it is in clockwise direction. So we have to take negative sign. So minus 4 multiplied by distance in between B and C, that is 2, which is equal to minus 8 kilonewton. Now we will move to the next point A. So if we observe, to the right hand side of the point A, there are two forces or 2-point load which is acting in downward direction. So moment is in clockwise direction. So remember, we have to consider only the moments on the right hand side. So we will take here with negative sign minus 6 multiplied by distance is 2, minus 4 multiplied by distance is 4. So when we calculate this, minus 12 minus 16 is equal to minus 28 kilonewton meter. So here bending moment at point B, here value is minus 8 kilonewton meter. We will draw bending moment diagram. For that we have to draw one baseline. We will plot positive numbers in upward direction and negative numbers in downward direction. At point D, bending moment is 0. So we will plot here the point 0. At point P, bending moment is plus 4 kilonewton meter. So here is the point P. So because of the positive number, we will plot the point 4. Then at point B, bending moment is minus 8 kilonewton meter. So here is the point B, and because of minus sign, I will plot the 8 number in the downward direction. And at point A, bending moment is minus 28. So we have to plot here the 28 number in the downward direction. Now we will connect all these points. If we observe the span CD, then it is uniformly distributed load. So we know that the bending moment will follow parabolic path, and the point where shear force is equal to 0 is having maximum bending moment, and that is equal to plus 4. So we will connect this point. So I will connect from this D to plus 4. Now we know that bending moment at point C is equal to 0. So here is the point 0. So I will connect here with parabolic path. Now if we observe the span BC, then there is only point load. So when point load, then the bending moment will follow linear curve. So here we will join these 2 points C and this 8 linearly. Now in the same way, in the span AB, there is only point load. So we will connect this 8 and 28 with linear line. And now at point A, we will connect with 0.